Should not be 89 kilograms. That seems wrong. All right. Yeah, I was going to say, he said 89 kilograms, and I'm like, that does not seem right. So I have up here the pounds to kilograms. They also have in your book, in a different section, they have kilograms to pounds. You can use either one. Should get the same answer.
I got 8.98.
8.98? That sounds better. He said 89. 89. I'm like, I'm pretty sure I'm close to 89 kilograms. That seemed high. So, what we can do is we can take this 19.89 pounds, and we want to get this to be kilograms. So if I know there is 19.8, I'm good at writing things. 19.8 pounds. And if you want to set up as a ratio, you can do with that as per baby. And we want to make that to be kilograms per baby. How could I set it up using one of the ratios that's available to us? We want pounds to be where? We want kilograms and pounds, but which one do we want on the top? Kilograms on the top, because I want the word pounds to cancel out. It genuinely does not matter if I use the 1 pound to 0.454, there we go. 1 pound to 0.454 kilograms, or if you use the 2.2 pounds to 1 kilogram. It does not matter. You should get about the same rate. So just because I have this one up here and I can actually see it in front of me, I'm going to use my 0.454 that's in the corner, which goes to 1 pound. So how many kilograms is this baby?
8.98.
That sounds better. I'm going to do it real quick because I don't have it written down. We have 8.989, I'm going to take 3 decimals, kilograms. So that tells us how much the baby weighs. Yeah, there's more. I got 9892. I rounded it a little bit. I just been keeping several decimal places. Well, to be fair, at first you had 89.
I was just saying a random number.
Okay. So, how does that help us? What are we going to do with that? Okay, divide by 1. There it is. Right back where we were. So this tells us how much baby we have in kilograms.
250 over that number.
Let's see. I want to know if this is the right dosage for this baby. We wanted the baby's weight in kilograms. What do we do now? What can I do? Let's go with how much medication does the kid take in a day? 250 milligrams. They just take it once a day? Every 8 hours. So how many times are they going to do that in a day? There are 24 hours a day. You can absolutely do this as a ratio, as a unit conversion. I could take my 250 milligrams per 8 hours, and we know that there's 24 hours in a day. So if we want to know how many milligrams they take in a day, we can do that. What is that going to give us? How many milligrams did they take? Or will they take? And then divided by 8. 750. You can also look at this and say, well, there's 3 sets of 8 hours in a day and do it that way, but this 100% works. So the baby takes 750 milligrams per day. So, how many milligrams per kilogram? How would I set that up? Because that is what the unit is that they're giving us for the safe dosage. They're giving us milligrams per kilogram here per day. This is like a real thing that like pharmacists do, guys. This is 100% so they don't kill the baby. If they're off by a decimal point, it can be very deadly to give medications in the wrong amounts repeatedly. So it's really important that we're super duper safe about medications. And it's always a good idea to double check the medications and make sure you're getting or giving a safe dose.
You never give baby spin?
That's why we should never let it, like...
1, don't know what that is. 2, recording this class. Be careful what you say. I'm standing right here with a microphone. Cole. Just putting our name on it.
Stop calling me Ed.
So we want to know about the milligrams per kilogram. How would I set that up in a ratio? Milligrams per kilogram. How many milligrams of medication did they take? 750. How many kilograms does the baby weigh? 8.989. Is that in the safe range of between 75 and 150? How do I get that to be a single number? Type it in the calculator and divide it. 750 divided by our 8.98. Mm-hmm. So we got our 83.435, blah, 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 blah. What's up? Yeah, there are many pathways through this. I was just taking the one that was being spoken aloud. So, is this in the safe range? Yeah. Between 75 and 150. This is between 75 and 150. It's strong enough to do what we need it to, so it's over that 75, but it's weak enough to not, hurt anybody. Okay, so these unit conversions show up a lot of places. There's a lot of things in the real world that deal with units, because the world is built in stuff. Inches, feet, centimeters, blocks, bricks, humans, shoes, tiles. The world is built out of stuff. You can measure out of a whole bunch of different things. So we're going to practice with a lot of unit conversions on this page. So this next one is kind of weird, but it's a good one. Or at least a good, kind of weird one. So you own a 1 acre lot. A mile squared is 640 acres. My screen's up to sleep. I'm fixing it. I know. Tired and done with my nonsense. I leave. That's not right. All right, so first thing we need to know is how big is our lot? We have 1 acre, which is great, but that doesn't tell me a darn thing about how big it is. Especially when everything else we're talking about is talking about feet and inches, having things measured in acres doesn't really help us. So we're going to need to switch this away from 1 acre and into some other unit of measurement. Luckily, they give us a couple right there. So I'm going to set this up as like a series of ratios. This is how you can do it in like the single line. So if I own 1 acre, I'll write that again so it's slightly, here we go. So not overlap. 1 acre. And I know, gentlemen, that 640 acres is the same thing as 1 square mile. So I could put my 640 acres is 1 mile squared. So that's going to get the word acre to cancel out. Miles is all well and good, but they're asking me about inches, so we should get this down into inches. I don't have anything about inches in here, and I especially don't have anything about inches and miles squared. What do we know?
Square root.
We're not going to square root. We don't have an equation.
Yeah.
We don't have an equal sign. What do we have that might help us get from miles down all the way to inches? Well, we're gonna use a unit here. What units do we have? Feet. I know about miles and feet. 5 tomatoes. 5280. 1 mile is 5,280 feet, which is all well and good. If I know that 5,280 feet is 1 mile, is that going to cancel out miles squared, though?
No.
What do I need to do to get it to be miles squared? Square it. So we're going to take our 5,280 and square that to get feet squared, and our 1 squared to get miles squared. I'm going to move this. Ooh, that did not move everything. There we go. I'm going to scooch this down so it's like over the line. That way we can actually see when I wrote stuff. That will let us take our miles squared and cancel them out. That gives us square feet, but we want to know about some inches. How do I switch inches to feet? Or feet to inches? Because I now have feet that is not... Yeah, 5280. That is given to you on your page up here. Right here. So that I have feet in my problem, and they're asking me about inches. What do we know about inches and feet? How many inches in a foot?
12.
I am hearing way too many different answers on this. How many inches in a foot? 12 inches in a foot.
I was thinking yards at first.
There are not 3 inches in a foot. There are not 9 inches in a foot. There are 12 inches in a foot. I heard several answers from several different people, not just one person.
3 feet in a yard.
We're not in yards, and we don't want to be in feet. I know that there are 12 inches in 1 foot. Again, I have feet, not feet squared. So what do I need to do to get square feet? Square it. So which means I have to square everything. 12 squared for inches squared. 1 squared for feet squared. That's going to get the feet to cancel out, and we're going to figure out how many square inches of land we own. We're just going to deal with our area for first. So let's simplify this because this is getting to be a hot mess over here. So what I have in the numerator is I have 1 over here in the acres. So I have 1 times 1 times 5,280 squared, ew,
Which is
times 12 squared.
278,784.
Which what we can do is actually use the calculator, which has some special things inside of it. Like if you guys use the yellow calculators, you'll be able to see. Hang on, try and, oh, come on, get out of all the things. I need to get my calculator. Because my very favorite button on this calculator, second column, third button down. Fractions, that look like fractions. And in that numerator, I can put my 1 acre that I own times, let me see, where were we? The 1 mile squared
Times 5 to 8.
times 5280 squared times 12 squared for our inches. And that's all over our 640 acres times the 1 squared times the 1 squared. So those are all the things, just without any of the words. It's the same pieces. The calculator will do it for us. We should get 6,272,640.
Yeah, that's 600.
What unit is this? What is it? 6,272,640
Inches.
regular inches like this?
Cubic. Or square.
Inches squared.
Yeah.
This is the area of my land. So if I have, ow, static shock, directly under my fingernail, that hurt. Oh my gosh. All right. Here's my beautiful acre. Ooh, it's so pretty.
Acres.
It's an acre.
It's so
It's my beautiful acre. It's lovely.
acres.
So now I have my 6,272,640 square inches. If I get 1 inch of rain, what am I going to do to find the cubic inches of my 1 inch of rain off the surface here? Times our 1 inch. Everything's in inches. I'm in inches squared here. So how many cubic inches of rainfall if I have a height of 1 inch? If I times it by 1,
Same number.
what changes? If I times that number by 1 inch, what? The only thing that would change would be our unit. If I change it from inches squared and I multiply it by a height, that's going to give me inches cubed. So this is my area. To get my volume, we multiply it by our 1 inch. And so the amount of water that fell on our plot of land is that same value, our 6,272,640 inches cubed is our volume. This is a volume thing. So now they want us to convert the other way. Because now I have cubic inches and they want us to do cubic feet. So I'm going to bring down what we know, my 6,272,000. All right, guys. Log back in. We've got our cubic inches here. And they want us to put it back as feet. How do I go from inches to feet? What do we know about inches and feet? Say it louder. 1 inch is 12 feet. No. That's what I heard. 12 inches is 1 foot. Make sure we're being careful. 1 foot,
Oh, that was Moses.
12 inches. That's one of those finish the thought in your head. And also it helps to not be trying to have 2 to 3 conversations at the same time.
I was like, wait, what is this?
I'm just saying. Will this fix it? I've got inches and feet. What do I need to do? Cube it. I need inches cubed to cancel out. So I need to cube my inches, which means I need to cube absolutely everything. Cube everything. That's going to make my inches cubed cancel out with my inches cubed. And we're going to be left with cubic feet. So we're going to have our 1 cubed on the top, which is just going to be 1. And in our denominator, we have 12 cubed. So when we put this in our calculator to help us with that, because ew, we're going to have our fraction that has our 6272640 over 12 cubed. We hit the little up arrow over here on the left. That gives us our any exponent. Hit the 3. There's my 12 cubed. I can hear somebody's music all the way over here.
Walker, turn on your game making music.
So this, our 3,630 is what we get. We get 3,630, and the only unit I have left is cubic feet. In the X right here, that's a 3. Is that the one? Cool. I don't know. There's really not much space on the page. I'm just trying to squeeze things in. All right, so we got 3,630 cubic feet. That's a much more manageable number than the 6 million. And what we're going to do is we're going to see how heavy that water was. Because sometimes you have little bridges on our land, or we have like culverts. We need to make sure things are safe. So we need to make sure there's enough force to withstand the weight of this water. And it was only 1 inch of rain, remember that. So if 1 cubic foot of water weighs 62 pounds, and we had 3,630 cubic feet, how much did that 1 inch of rain weigh? How are we going to do that? So the thing that I know is my 3,630 cubic feet. What can we do to make that be pounds? What do we know?
My lucky number is 156.
We're on C. How are we going to set this one up? It's very much like the ones we did in the other two. Uh-huh. That's the question.
0.4543.
Mm-hmm.
30 will be on top.
Yep.
And
Multiply by 3.
60 will be on bottom. Or 62.
If I set it up with the 62 pounds right here, that's 1 cubic foot of water. Does that cancel out?
So flip it.
Flip it. I want to wind up with pounds, so I want that to be on the top. So if we know what we want our end unit to be, set that up with on top. I want the weight on the top, so I want to wind up with pounds on the top. So we know 62 pounds per 1 cubic foot. So now my cubic feet are going to cancel out, and we're going to be left with pounds. How heavy was this rain?
1 cubic, 60
For each foot? I had 3,000 feet. 3,630 feet. Yep. Multiply across.
225,000.
Yep. 200,000 pounds.
That was close.
All right. Last one on this one. How many gallons would that be?
64,000.
No.
Is that close? No.
No. Because you are just randomly guessing. You're not trying even a little. Even if you wound up exactly on the nose, I wouldn't tell you. Because I know you just blind guessing.
Yeah,
I know. Shock. This is my shocked face. All right. So what we know is that we have 225,060 pounds. How can I switch that to be gallons?
1 gallon.
All right, guys, I'm doing work right now, so the other conversations need to stop. It's rude.
Gallons on top and then put the down.
Gallons on top. And the pounds will be on the bottom. That's what we have our unit for here. We know that 1 gallon of water is 8.3 pounds. So what are we going to do with our 225,060 and our 8.3? Divide them. Yeah, you're exactly right. So how many gallons is that? So then let's round that to 0.7. No, you said 64,000. It's 27,000. That is not close. That is triple. You were off by a multitude of 3. No. What's up? Yeah, that's 1 inch of rain. That's this much rain that fell over an acre. An acre in real life is 3 to 4 houses with their yards. So, like if you're in a neighborhood that has like separate houses and you pick 4 houses, everybody's yard, that'll be about an acre. So when we get an inch of rain, that is 27,000 gallons of rain, of water.
That's 225,000.
So think about the rain that falls on the roof of your house. And the reason roofs have to be so strong is they're catching all of that rain over and over and over, and it slides down the roof and it goes into those gutters that are held on by like 3 tiny nails. All that rain from the whole house, that's a lot of weight. It's a lot of weight. So these kinds of unit conversions come up in safety, not just in medicines, not just in math teachering things, not just in measurements. It comes up in safety. Water is heavy. Water is super heavy. So when if you're doing building things, if you're doing safety inspections, if you are just trying to plan a house and replace stuff, you got to know what things weigh and how it's going to impact what you're doing. Okay? So the next one I think is, I find really interesting, but it's a lot of the same thing over and over again. It's very similar to this. It's just converting light years down into,
Light years.
miles per second into light years, how far that is.
Oh, that's too far.
It's a big one. And how far away, and it winds up with a lot of scientific notation. So we're not going to wind up with a ton of scientific notation stuff going on. We shouldn't. So I'm going to put this up. And I'm going to point one thing out up here.
10 to the 12 to 5. 10 to the 12 to 9? No, actually, 5.8
semester?
Uh-huh.
times
What about
10 to the
December?
12.
We are going to come back from break and be working on our project. And then we're reviewing for finals.
It has error ended.
So, yeah, this homework 3.3, is the last, like, independent homework. Aside from, like, chapter reviews that we're going to do to get ready for the final.
Oh,
It's the last one.
1 light year is 6 trillion times.
So I encourage you guys to look at the last one. It's really interesting. I love the space stuff, but it does wind up being obnoxious numbers because space is big. And we don't have units that big because we live on a planet. What's up? The numbers are really, really big? Is that what we're saying?
No, you're talking about the space.
Yeah. I find it really, really interesting, but it's like if I wasn't a math teacher, I'd probably be a science teacher.
2.7 is
So I find it really, really interesting, but if it winds up being obnoxiously big numbers and they wind up in scientific notation, and that's a whole lot, and we're not going to see that really. So
too much.
I find it interesting, but if you don't worry about it. If you do also find space interesting, check that one out. It's kind of interesting. Then if you had your book, you could look at that question.
Yeah, I'm gonna go.
But you don't carry your book, would you?
Yeah, that's the error I need to